dedicated to those who will be watching this later today at home. So, equations of sinusoidal functions, our third lesson. So, given a function in this form, right, and that's on your formula sheet, y equals a sine bx plus c plus d, we have the following information that we can get out of the equation. So, just straight looking, we get the midline value, right, which is the median. Now, if we're given a graph, we calculate the midline by taking the maximum plus the minimum and dividing it by 2. If we're given the d value, then we have the midline. If we're given the d value, we want the equation of the midline, it's going to be y is equal to d. So equation is always of the form y equals. So that would be y equals d. If I want to get the amplitude from a graph, it's max minus min over 2. From the equation, it's just the value of a. So if you're given the equation for free, you get the median, the midline, which is the d value. That's your vertical displacement, up or down, right? So if you have positive 5, it's up 5. You have negative 3, it's down 3. You have your amplitude from the equation. Amplitude is the distance from the middle to the max or from the middle to the min. So that gives you your range. If you take the d value and you subtract a, you'll get down to the minimum. If you take the d value and you add a, you'll get up to the maximum, right? Because we vary from the midline, we go up, the amplitude go down. Range is min, so that's your min. Less than or equal to y, less than or equal to, and that will be your maximum. From the equation, you've got b, you get the period. Period is 2 pi divided by d. That's on the formula sheet. If it's an exact value, then we're just going to do a reduced fraction. So if you had 2 pi over 10, that would reduce to pi over 5. If they ask it as a decimal, 2 pi over 10 would be 6.28. Okay, you just plug it in your calculator, 2 times pi divided by 10, and you would get that value, right? So do they want the period as a decimal, rounded to the nearest hundredth? Do they want it as an exact value? Either way, we can get that. The domain for all sinusoidal functions is the set of all x such that x belongs to the reals. If we're talking in a particular context, then the domain may be greater than or equal to 0. So if we're talking time, something like that, our domain might be greater than or equal to 0. The start point, this is where the graph meets the midline closest to the y-axis and it's going up. So this would be the start point, right? Y-axis, midline, graph goes up. Okay, that's your start point. So let's analyze this equation. Given the equation, y equals 3 sine 7x minus 2 plus 5, what can we say? So let's start with the easy stuff, the midline. What's the midline? So the midline equation is y equals 5. Right? So it's y equals d, the midline. We're talking about this in terms of vertical displacement, and the vertical displacement is up 5. We're going to go up 5. From 5, the amplitude tells us how far to go to get to the minimum. So if the amplitude is 3, the middle's at 5, what's the minimum? Middle, 5. Amplitude is 3, what's the minimum? Not 3. 2. So the minimum is d minus a is 5 minus 3 is 2. What's the maximum? It's a formula. Sitting here. 8. What's the distance from the minimum to the maximum? How far apart are min and max? These fingers, right? Number 2, 3. 6. What's half of 6? 3. Good. That works then, right? The amplitude is half the distance from max to min. From 2 to 8 is 6 units. Half of that is 3. Good. That's what the amplitude is supposed to be, is 3. The period. What's the period? Two pi over b or 2 pi over 7. That's an exact value. If we need it as a decimal, we can just go into our calculator, punch in 2 pi divided by 7 and get the decimal. What's the start point? So it's negative c over b, comma d. So a negative of a negative is positive, so it's 2/7. Right? Negative 2 over b. The negative of negative 2 over 7, which is 2 over 7, comma 5. That's where it would start. So what is this period? So let's fire up our calculator. Just keeps coming up with that. Reset this thing. So if I reset it, right, I mean, we need to be in radian mode. That's all we ever need to be in. So when you reset your calculator, it's good. If you run into any problems with your calculator, just reset it. So if I want 2 pi divided by 7, that's going to be 0.897, so 0.90 rounded to the nearest hundredth. Okay, so 0.90 units. So if I want to graph this, let's go to y equals. So 3 sine 2x, or sorry, 7x, 7x minus 2, close bracket, plus 5. Now the other thing I'm going to graph, I like to graph the midline. Like to see the midline. Is that in the right place? Does it split the thing in half? Also, we're going to look for the start point. Right? So we said we think the start point is at 2 over 7. Right? 2 over 7, whatever that is. We can work that out in a second. All right, let's go into the window. So what window am I going to use? So here's where the period comes in. The period is 0.9. So I don't want to go from 0 to 100. Right? I want to go from, let's say, 0 to 1. If I go from 0 to 1, we should see one complete period in a little bit. Maybe I go 0 to 2, so we see 2 complete periods. Okay, we change it. Let's go 0 to 2. Let's see 2 complete periods. Use a scale of 1. We know the minimum is 2 and the maximum is 8. Let's go from 0 to 10. It'll give us a little bit top and bottom. So the x scale we use is 1. Let's take the y values from 0 to 10. Again by 1s. Okay, that's okay. Before I hit graph, what's 2 divided by 7? Because I think that start point is 0.285, like 0.29. Okay, let's hit graph. So we should see a couple of cycles, a little bit more than 2 cycles. There's 1 complete. There's 2, a little bit. There's my midline. Okay, so the period helped us figure out the x window, right? Period is 0.9. So you don't want to sit there and go, oh, let's go from 0 to 10, right? All of a sudden we're going to see like 10 squished in, 10 of these cycles squished in there, right? 2 is plenty. All right, the min and the max helped us set our y values, right? Our y goes from 2 to 8. We said, let's go 0 to 10. There'll be a couple on the bottom, a couple on the top. We'll have some room top and bottom. Middle's running at 5. This point here, that's the start point. So we looked at 2 over 7 is 0.29. So if I find the intersection of these 2 points, second calc intersect, right? Because we got the midline going up. oops. So if I go to that point, so we're going to see just on here, it should be around 0.29, right? 0.287, blah, 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 right? So let's hit enter 3 times to do an intersect. So 0.28571429. So if we quit, which you can't do, don't quit. Never say die. Apparently I can't quit. Okay, 0.2857142857, right? That's the number we had off of the graph. So that's times the start point, right? We look along the midline to the first point on the graph where it's going up. That's our start point. So all of this gave us the information we needed to set a really nice window to take a look at the actual graph, right? All of this. Where's the middle? 5. How low do you go? 2. How high do you go? 8. Most importantly, what's the period, right? So what would happen if I just said, oh, window. All right, let's go negative 10 to 10. What's that going to look like? It's going to look like that. Does that look good? What we want to see? No. Right? That's way too much. Why? No. What's wrong with that? Like, it's not even, right? Like, there's the minimum there, and there's minimums there. Like, it's not even right. It can't draw that many cycles, right? Not right. These are too low. See, this looks like it's going down and then coming back up again. I don't know if that's an optical illusion or that, but no, right? Use the B value to get the period to get your X window, right? So 0 to 2. 2 cycles, really nice, smooth curve, looks good. All right, so how do we apply this? The far north. It's called the land of the midnight sun for good reason. During the summer months in some location, the sun can be visible for 24 hours a day. The number of hours of daylight in Iqaluit, Nunavut, can be represented by the function. Y is equal to 8.245 sine 0.0172x minus 1.3929936 plus 12.585. Where x is the day number in the year. So if x was 1, that would be January 1st. If x were December 31st, or if it was December 31st, x would be 365. If it was February 1st, x would be 32, right? 32 days into the year. How many hours of daylight in Iqaluit occur on the following days? So the shortest day of the year. How are we going to calculate how many hours of daylight? Shortest. What's the calculation? Numbers are there. What are you going to do? D minus A, right? What's D? So it's B minus A, 12.585 minus 8.245. Which is, all right, what do we got? 5's there, that gives us a 0, a 4, a 3, a 4, a decimal point. So on the shortest day of the year, you'll have 4.34 hours. Right? 0.3 hours would be like 0.3 of 60, would be like 18 minutes, right? So 0.3, 4 hours, 18 minutes. So that's decimal time, right? If it was 4.5, that'd be 4 hours, 30 minutes, right? 0.5 would be half an hour. But it's 0.34. Longest day of the year. How do we get the number of hours of daylight for the longest day? D plus A. So 12.585 plus 8.245. Okay, 0 carries 1, 13 carries 1, 7, 8. 20.83 hours. So 0.83, 0.8 of 60 would be like 48. So it's about 20 hours, 50 minutes, just shy of 21 hours of daylight. Okay. On the longest day of the year. Go a little bit further north, up to 24 hours. Right? If you're at the pole, the sun will never set. It's going to circle around you. In some years, June 21st is the longest day. What do we call June 21st usually? Summer, right? Summer. summer solstice, right, which is the longest day of the year, June 21st. Suppose the sun were to set at 11:01 p.m. on June 21st. At what time did the sun rise? Well, we know there were 20.83 hours of daylight, right? So we're going to back up 20.83 hours. Now we got to ask then, well, what's 0.83 hours? So we're going to take 0.83 times 60. Get out of that. So 0.83 times 60, right, tells us 49.8 minutes. 49.8 minutes. So let's call that 50 minutes. So from 11:01 p.m., now this is where the 24-hour clock comes in handy. What's 11:01 p.m.? 23:01. And from that, we're going to take away 20 hours. So let's just start with hours. So that'll take us to 3:01. And now we're going to take away 50 minutes. So if it's 3:01, you go back 50 minutes, where are you? 2:11. Right? So just think, go back an hour, you'll be at 2:01 and then add 10 minutes, right? So if you go back an hour and add 10, that's the same as going back 50. Okay, but it's easier to go back a full hour, 2:01, add 10, so 2:11. So 02, the 24-hour clock, 0211. Sunrise was at 2:11 in the morning. Sunset was at 11:01 or 23:01 in the evening. What is the period? How do we get the period? Which formula do we use? You look up top of the page, it says period is 2 pi over b. Okay, what's b? .0172. So 2 pi divided by 0.0172. Okay, somebody want to do that? What do you get? Okay, so the test is next Monday. So good. It's not on the same day as the other tests. What's 2 pi divided by 0.0172? 365.30? I've seen that number somewhere before, 365. What is that? Number of days in a year. That makes sense? Well, what we're doing here, right? We said it's the number of hours of daylight where X is the day number of the year. So when we put in 365, there's actually 365 and a quarter days in a year, right? That's why we have a leap year every 4 years. Sorry, a leap day, not a leap year. Every 4 years we add a day, because there's actually a little bit more than 365 days in a year, 365 and a quarter, so that kind of keeps us caught up. And we just had one this year, right? We added. So that period, if you plug 365 in there, right, you're going to, what it's going to do is the 0.0172 is going to change it into radians, right, which doesn't matter to us, but it's just going to change us into the units that the calculator is using. What does the value negative c over b? All right, so let's work that out. So negative c over b is equal to negative 1.3929936 divided by 0.0172. Okay, so negative is just going to be positive, right? So what we need to do is 1.3929936 divided by 0.0172 is 80.98. 80.98. Okay, let's call that 81. So 81, what day of the year is day 81? So let's figure out. So 31 days in January plus, let's go normal year, 28 days in February. So 31 plus 28 is 59. Okay, 81 minus 59 is 22. Right, so we would be like 22 days into March. So what happens around March 22nd? Yeah, spring. Right? Spring. So what this is saying is, if you graphed this, well, what would the graph look like? So then let's do this. So we're going, so I need to know, okay, so let's say there's 0. So we're going from 12, 4.34, so we're going to have like 4 up here. We go up to 20, right? So 20 up there, or 21, throw 24 up there. So let's say we go from 0 to 24, because we know our min is 4.34, our max is 20.83, right? So that helps us do that. Now, the midline then is going to be halfway between those. So the midline is, the midline is D. That's the midline. So it's about 12. So 4, there's 12. So there's the midline. The start point. So what that's saying is, that's day 81. So on day 81, that's the first time that we're going to reach the middle number of hours of daylight. Right? First time we're going to reach the middle number of hours of daylight for the year. Right? And then we know from spring, days get longer until we hit summer, right? Longest day of the year. So there's March 20th, whatever, 25th. There's July, right? Longest day of the year. Or June. There's September when we get back to the middle. And when we hit the bottom there, so there's December. Whatever, 20th, 21st, right? There's September. There's June. There's March 21st. So we hit the average number of hours of daylight on around March 21st, right? It's spring. Maximum, summer, back to the average number, right? So we just were here like a month ago and a bit, right? So the days now are getting shorter. Then we mess with our time zone to make things worse, but that only happened 1 or 2 more times. And then shortest day of the year and so on. And then that just keeps repeating. So if we graphed it, that's what our graph would look like, right? And we know that. We know we want to go from 4 to 24 about. Let's graph that 12.585 in the middle. We know this has to go for at least 365. So that's our period. And what else do we know? If we draw the midline in, we know when we're going to hit the midline. Right? And in this context, we know what that means. You're going to hit the midline at spring. That's when you're going to hit the median number of hours of daylight. Right? So half the year, we have more daylight than 12.585, and half the year we have less daylight than 12.585. That's what the median is, right? The middle. Okay. The depth. D, meters of water in a harbor. T, hours after midnight, can be approximated by the sinusoidal function. D of t is 5 sine 0.524 t plus 1.571 plus 12, where t is between 0 and 24. State the equation of the midline. Okay, what's the equation of the midline? Y equals 12, right? Y equals D. What is the amplitude? What's the amplitude? 5, right? 5 meters. Hence the max and min depth. So it just says state, you don't have to show any work. What's the minimum depth? It's the minimum. Okay, and you do need to show some work. What's the max? Okay, so no meters on there. So the minimum is 7 meters. Right? So from the middle, 12. If this height is 12 meters in the harbor, it's going to drop 5. It'll go to 7. From the middle, 12. It's going to go up 5. It'll go up to 17. Okay, it just says state. Well, no, then it says determine. So actually, you do have to show state the equation of the midline and the amplitude, right? Because those are just numbers you pick out of the equation, and then determine. So to get max and min, you really do have to do a calculation, right? So it's going to be d minus a. Okay, so 12 minus 5, and d plus a, 12 plus 5. Determine the period of the function. How do we get the period? 2 pi over b. Determine means show work, so we're just going to write 2 pi over 0.524. And say the period is 2 pi divided by 0.524. 11.99. There's 10. 12.0. What's period measured in? Hours. Okay. So the height, the depth, the amplitude, those will be in meters, right? They're y-axis things. So the y-axis, which is the height, that has to do with A and D, right? D is the middle. 12. A is 5. Go up to 17. Go down to 7. Distance from 7 to 17 is 10. Half of that is 5. Good, because the amplitude should be 5. Period. 12 hours. The 1.571, that if we do a negative C over B, which so far we're not being asked to do, that would just tell us the first time that the water reaches the middle, 12, and is rising. Okay, but so far we're not asked. Use the graph of the function to determine the depth of the water at 2 p.m. Okay, so what do we know? We needed all of that stuff, right? So we're going to go to y equals. We're just going to clear out what's in there. We're going to put in the equation, which we can no longer see. So y is equal to, what do we say, 5 sine 0.524 x plus 1.571 plus 12. Okay. But all the work we did was not in vain, right? We need this to figure it out. Okay, let's figure out our window. So they tell us the time goes from 0 to 24, so we'll go 0 to 24. Let's do that by 2's. Our minimum depth is 7, our maximum is 17. I always like to start at 0, so I'd go 0 to 20, but I think maybe going, well, actually 0 works nice, right? It'll give you 7 on the bottom and 3 on the top. So let's go from 0 to 20, right? So your y values are your min and max heights. Your x values are your minimum time and your maximum time. Y scale 0 to 20 by 1s, that's fine. Take graph. Okay, so we don't see anything hinky. We don't see 27 periods being drawn in there, right? Because we figured out period was 12 hours. So to see 2 periods, okay, they told us go 0 to 24, but we figured out, look, the period is 12 hours. We're going to see 2 periods. Do we see 2 periods? Well, it starts almost at the top. Almost at the top. So there's 1, there's 2. So 2, maybe a smidge over 2 periods. Cool. So determine the depth of the water at 2 p.m., hours after midnight. How many hours after midnight is 2 p.m.?
1,400
Yeah.
hours.
So if you go to the 24-hour clock, 1,400, that's 14 hours after midnight. Second calc. Value. Okay? Remember, anything on the x-axis is time. Put in a value of 14. And we get out a height, so determine the depth from the nearest 10th, 14.5 meters. Okay? You give it a time, it will give you the height of the water. What's the next one say? Ship that requires a minimum of 8.5 meters, misspelled meters, M-E-T-R-E-S, is in the harbor at midnight, by what time must it leave to prevent grounding? Okay, so we need 8.5, so let's go to y equals, right? Because y is depth. That's the depth of water in the harbor. Okay, so we'll put in 8.5. And then we'll graph. So it's going to draw a line across our graph at 8.5. Okay, so the ship is in the harbor midnight, and it's going to have to leave at this time here in order to avoid being grounded. It needs 8.5 meters of water to get out. So second calc, we want the intersection. So just move to the point of intersection. So 4.477. .0804 hours. But we want to know minutes. What time, right? If we're looking at a clock, we're not going to see 4.477 hours. So it's a little bit shy of 4 hours, 4.5, right? So 0.477 is pretty close to 0.5. So we know it's going to be sometime before 4:30 in the morning. So here's what we're going to do. If we quit out of this and we take our x, so when you run a calculation in the window, when you do a graphing thing in the window, the xy point that you get will be stored in x and y. So if I take x, which we know is that 4 point, subtract 4, okay, get rid of. So all I want is the decimal part of the hour, right? 0.477. So we're interested in this, 0804, right? And we're going to multiply that by 60. So times 60, right, which is going to turn that into minutes. So 4 hours, 28.6 minutes. So on the clock, it would read 4:28, right? Because it won't go to 4:29 until it is 4:29. Okay, so our clocks, if they don't have seconds, like so this one up here, right, it says 14:49, it's going to stay there for an entire minute, then it'll just be 14:50. So we're going to see 4:28, right? So we want to, if I'm that guy, I'm out of there at 4 in the morning. I'm not going to wait 28 minutes just to try it out, make sure that we can't get the engine started. Well, we're not getting out of here. If you wanted seconds, you want to be precise, subtract 28, okay, because that's decimal minutes, multiply that by 60, you'll get seconds, so then it'd be 37.4. So seconds are one thing we do measure as decimals, right? So when we measure seconds, we measure like, you know, for timing track and field or something, we time to 100th of a second, so you would get like 37.48 seconds. Okay, we don't need that, right? It'd be 0.49 seconds here rounded. Unless we're timing to 1,000, then it'll be 0.490. Okay, but 4:28 is good enough, right? 4:28. Any questions on this? So we didn't worry about the negative C over B. What does it mean? Okay, what it means is it's the time that we first reach 12 hours of water when the tide is coming in. So be aware of that, right? As the tide comes in, we get more water. It's going up to 12. That'll happen at negative C over B. Then it'll peak. Then it'll start going down. So you may have to sort of sketch it out, see what it looks like, or graph it to see what it looks like. Okay, now we did graph it. Let's look at the graph again. So we're starting out pretty much at high tide, right? Then the water is dropping. And then, so if the midline is here, that's where negative C over B would be. That would be the time that we first reach the midline and the water is going up. Okay, so keep in mind, you may have to sketch out something, look at it and say, when is the water reach the middle and it's going up? That's going to be at that time then. Okay, so we could run, yeah, let's do it just for the heck of it. We got nowhere to be. So let's find out what the, what's the midline? 12. All right, hang on, got to go to y equals. So I'm going to set that from 8.5 to 12. So we get the midline, right? And then we'll look for this. So it'll be somewhere around here. That was low. Okay. Second calc intersect. Get rid of that. 1, 2, 3. So 8.99, so like 9. So the reason this isn't going to match out is because it's actually going to go backwards. When we do negative c over b, it's actually going to go back here. So as this goes, it'll go back to here and give you that time, right? To say before midnight, that time. That's why we didn't look at it. Okay, and it didn't matter here, right? We don't care. What we care about is when can we get out of there where we have the amount of water that we need. Anybody ridden the London Eye? Well, I think we asked that before. So this is actual reasonably real numbers for the London Eye. The height of a pod on the London Eye Ferris wheel can be modeled by the equation h of t, 67.5. So height is in meters and time is in, I don't know what, but we'll figure it out when we get to period. How long does it take to go around?
About 30 minutes if I can remember. This is like.
Yeah, no, you're right. Yeah, it's about a half an hour. Okay. So when we work out the period, if it comes out to 30, we'll know we're in minutes. If it comes out to like 1800, we'll know we're in seconds. Okay, so we'll figure it out. So it requires a little bit of inside knowledge, but we've got that. Okay, so height is in meters. Height. Meters. Time, I think, is in minutes. Okay, we'll verify that in a sec. All right, what do we know? So we know A is 67.5. D is 69.5. B is 0.209. C is negative 1.571. All right, where do we start? Start in the middle. What's in the middle of a Ferris wheel? The axle or the hub. So, the height of the hub of the London Eye is what? What's the height of the hub? Nope. Where's the hub? Center. Where's the center? Midline. Where's the midline? B. So 69.5. So the hub is 69.5 meters. What's the minimum? How do you get the minimum? D minus A. Good. This is not on your formula sheet, right? The only thing you're getting is y equals a sine bx plus c plus d. Period is 2 pi over b. And if you're good, I'll give you the start point is negative c over t. So the minimum is d minus a, which is 69.5 minus 67.5, which is 2 meters. All right, what's that mean, 2 meters? Why is the lowest it gets 2 meters? Yeah, it's not hitting the ground, right? So there's a platform, you get on the platform and you walk up to it, right? The car is going to be 2 meters from the ground. So it's got some clearance on the bottom. How high does it go? So max is d plus a, 69.5 plus 67.5, which is what, 137 meters? Okay, so you will go as high as 137 meters, right? So that would be pretty close to a Canadian football field from end zone to end zone. You got 20, 25 yard end zone, you got 150 yards. It's going to be fairly close to that. So if you've ever sat at McMahon Stadium, if you imagine London Eye plunked down, it would go from end zone to the end zone. Okay, what else do we know? Well, period, right? We can get the period. So period is 2 pi over b, which is 2 pi divided by 0.209, which is how much?
30.06.
Sorry?
30.06.
30.0, so it was in minutes. So 30.06 minutes. It's about a half hour, right? Because it's not a thrill ride, it's a sightseeing ride. So, you know, taking around once in 30 seconds, while that might be thrilling, going would not be conducive to sightseeing. You just have what? It's like my stomach is still up there or down here. I don't know if you could spit. How many G's would you be pulling? That would be the question. Yeah. So let's strap you in. It's like the negative G's you get on the drop of doom, or it holds you up there and lets you go. What else have we got? So we got start point, right? So start point is negative C over B. So negative 1.571 divided by 0.209. So negative, you know, don't bother putting that in your calculator. You say negative is going to be positive. So I don't need to worry about putting in two negatives. So what's 1.571 divided by 0.209? Bless you. So 7.5. Okay, so wait a sec. If it takes half an hour to get around, so 15 minutes. It's going to take 15 minutes to go from the bottom to the top, right? But it's going to take 7.5 minutes to go from the bottom up to the height of the middle. Then another 7.5. So remember, periods are split into 4 parts. So you think about the London Eye, period's half an hour. Split that into 4. 30 divided by 4 is 7.5. You get on at the bottom, in 7.5 minutes, you'll be at the height of the hub. Another 7.5 minutes, you'll be at the top. So you've gone from the min to the middle to the maximum. Another 7.5, so 22.5 minutes. On the way down, you reach the hub again. And then in another 7.5, 30, you've completed one complete cycle, and it's time for you to get off. That's all you paid for, probably. So that 7.5 makes perfect sense, right? That's when you go from the bottom, so that's when you reach the middle, and you're going up. Okay? So in the context of the whole scenario, that's what it said, right? Analyze the scenario. So let's just kind of put that in. It takes 7.5 minutes. 7.5 minutes from when you get on until you reach the hub. Until you reach, God, that's right. From when you get on until you reach the hub, the middle, right? Until you reach the middle. Right, or the hub. So, okay, let's see if we can draw a little graph here. So we know we go from 2 to 137. We know that the middle is sitting here at 69.5. We know that we start at the bottom, we go to the middle, we go back to the top, come back down to the bottom. That's 30, that's 15, that's 7.5, that's 22.5. So we want to graph this. Let's graph this. What's the equation? 67.5 sine. That's not what we want. That's not what we want. On. Turn on. Calculator doesn't work. Yeah, calculator works. 67.5 sine. Actually, no, it's better to clear that. Clear. 67.5 sine 0.209 x minus 1.571 without the minus sign. Insert a minus sign. Minus 1.571 plus 69.5. And I always like to throw in the midline, so I'm going to do that. Window. Hey, we've done all the analysis, right? We know it takes 30 minutes to go around. So let's go from 0. Let's do 2 cycles. Let's go from 0 to 60. And you know what? We'll do that by 7.5. So every tick, we should start at the bottom. At 1 tick, we should see it hitting the midline. 2 ticks, the max. 3 ticks, back to the midline. 4 ticks, back to the bottom, etc. And let's go from 0 to 140. And let's go by 20s. Let's go by 10s. 10. So when I hit graph, we should not see a garbage graph, right? So if you're not getting the period right when you're graphing something, if you haven't figured out the period, then your x values are just kind of random numbers you chose. You're not really going to see much. If you're careful about it, we get on at the bottom. 2 ticks in, we hit the max. 4 ticks, 2, 3, 4, half an hour. Right? 60 minutes is 2 periods, 2 cycles. Here comes the midline. There's our start point, 7.5 minutes. Okay, second calc. Intersect. Oh, why is it there? Not bad. Great. 1. 7.5, which is the number you got, right? When you guys calculated, you got 7.516. I cut you off 7.5. It's 7.5, right? That's kind of neat. Give us an equation. We can draw you a picture. We can analyze the situation and say, well, here's your minimum, here's your maximum, here's what the period is. Use that to set your x values. Your min and max, use that to set your y values. We can go further by saying, when does it reach the midline and it's going up, so we can graph the midline, right? Say, when do we reach it? Well, 7.5 minutes in, right? It's got a 30-minute period. So this, well, I kept going. So that's just the first cycle, but there we are, 30. It all matches up. And we're done here.